Hello, night travelers, those quiet souls who wander gently through the hours of darkness, seeking calm amid the nocturnal symphony. Welcome back to the Night Observer, a place where minds come to rest, where worries soften, and where sleep arrives slowly, guided by thoughts of the vast and mysterious universe. I have lit a small bonfire once again. We gather around it, warming our hands, listening as the universe tells its stories. Tonight, we lift our eyes toward the sky and allow ourselves to drift into the great ocean of space. Take a slow, deep breath. Let your chest rise and feel the weight of a long day ease its grip. Allow the fire's warmth to carry your imagination outward. Picture yourself resting in a quiet vessel of thought, floating across a velvety black sea, where the light of distant stars weaves an endless tapestry of existence. Tonight, our journey moves beyond the familiar outlines of the Milky Way. We step into one of the most profound intellectual adventures of modern astronomy, the search for solitary travelers from the void. Welcome to 3I/Atlas, Travelers from the Dawn of the Galaxy, a story of the third interstellar visitor ever identified, an object carrying secrets from the earliest chapters of the universe. We will explore one of astronomy's quiet mysteries, the wandering, homeless travelers of space. Settle in for our reflection on homeless souls, the concept of interstellar objects. There is nothing to analyze or memorize. Let these words flow gently, like a stream of faint starlight, carrying your thoughts freely through the darkness as we listen to the silent breath of objects passing through our solar system, shaping reality in ways unseen. Defining stateless souls, within the vast disk of the Milky Way, home to between 100 and 400 billion stars turning slowly for more than 13 billion years, we are accustomed to order. Planets, asteroids, and comets are typically bound to a parent star, tracing closed elliptical paths under the steady pull of gravity. Yet the universe also harbors outsiders, interstellar objects, or ISOS. An interstellar object is an astronomical body that drifts through interstellar space, bound to no star. These solitary travelers were once born within a stellar system of their own, but violent collisions or turbulent gravitational interactions during the era of planet formation cast them adrift. When one of these objects happens to pass through our solar system, astronomers call it an interstellar interloper. Imagine them as ships without a harbor, gliding through the cold emptiness between stars, where matter is so sparse that only a few hydrogen atoms occupy an entire cubic meter. Within them, they carry a chemical memory of worlds we may never directly witness. Mathematical signatures, recognizing a visitor. How do astronomers know that a faint point of light on a telescope screen is a visitor from beyond, rather than a familiar member of our solar system? The answer lies in the mathematics of motion. The clearest clue is orbital eccentricity. Any object gravitationally bound to the Sun must follow a closed orbit, with an eccentricity less than 1. Interstellar objects, however, arrive on hyperbolic trajectories with eccentricities greater than 1. Their paths are open curves. They enter the solar system from the depths of space, swing once around the Sun, and then vanish forever into the darkness. Equally telling is their residual velocity, the speed they retain after escaping the Sun's gravitational pull. These travelers move far faster than the solar system's escape velocity, which is about 42 kilometers per second near Earth's orbit. Oumuamua entered at roughly 26 kilometers per second relative to the Sun at infinity, while the third visitor, Atlas, reached a remarkable 58 kilometers per second. The few visitors we have met. Though theory suggests that interstellar debris is abundant, with perhaps 10,000 such objects passing through Neptune's orbit at any given time, humanity has confirmed only 3. 1. Oumuamua, 2017. The first known visitor, discovered by the Pan-STARRS telescope in Hawaii. Its name means first messenger from afar. Oumuamua remains deeply puzzling, elongated and narrow, dark red in color, and lacking the familiar gas halo or tail of a comet, despite its close approach to the sun. Its unexpected acceleration as it departed sparked intense debate, including speculation about unfamiliar physical processes. 2 I/Borisov, 2019. Discovered by amateur astronomer Gennady Borisov, this object appeared far more familiar. Borisov displayed a bright coma and a tail 14 times the diameter of Earth, confirming that icy bodies from other star systems can closely resemble our own comets. 3. I/Atlas, 2025. The largest and fastest of the three, Atlas was discovered on July 1, 2025. With an orbital eccentricity of 6.14, its trajectory is almost a straight line slicing through the solar system, a fleeting visitor from unimaginable distances, physical and chemical signatures of distant origins. Interstellar objects challenge our traditional categories of asteroid and comet. Structure of ice and dust. Once described simply as dirty snowballs, comets are now better understood as complex mixtures of minerals, organics, and ice. Observations of 3 I/Atlas suggest an icy dirt ball structure where rocky material dominates. Its nucleus measures less than 1 kilometer across, yet its mass is estimated at around 33 billion tons. Chemical anomalies. Atlas's composition is striking. Observations from the James Webb Space Telescope reveal a gas halo dominated by carbon dioxide, with an 8-to-1 ratio compared to water, 16 times higher than that of typical solar system comets. Nickel vapor was detected, while iron was notably absent, a rare and puzzling combination. These clues point to formation in an extremely cold, carbon-rich region, far from its parent star, traces of deep time. Perhaps most remarkable is age. While our solar system is 4.6 billion years old, 3 I/Atlas is estimated to be between 7.6 and 14 billion years old. It originates from the Milky Way's thick disk, home to some of the galaxy's oldest stars. Atlas has traveled since the era when the first heavy elements were being forged. Why these travelers matter. Each interstellar object passing through our solar system is a quiet reminder that the galaxy is not a collection of isolated islands. Matter moves between stars, exchanged over tens of light years and billions of years. Oumuamua, Borisov, and Atlas are not mere rocks or ice. They are messengers from distant nurseries of planet formation. They remind us that the ingredients of worlds, and perhaps of life itself, are widespread throughout the Milky Way. Every atom in your body, like the dust carried by Atlas, was born in ancient stellar explosions. In that sense, we and these silent travelers share the same origin. We are all quite literally shaped from the same enduring stardust. Night travelers, our journey does not end with the familiar spirals of the Milky Way. Tonight, we drift gently backward in time, returning to the first 2 wandering souls that broke the long silence of our solar system. Visitors who prepared the way for the later arrival of 3 I/Atlas. Welcome to the precursor visitors, Oumuamua and Borisov. There is nothing here to analyze or memorize. Allow these stories to flow like a quiet stream of starlight, carrying your thoughts freely through the darkness. Let your breathing slow with each sentence as the universe softly rocks you toward rest beneath its eternal glow. Humanity's awakening to visitors from beyond. For centuries, humanity believed the solar system to be a closed and orderly haven. From the giant planets to the finest grains of dust, everything seemed bound forever to the sun's gravitational embrace. Yet the universe, as it often does, proved larger and more subtle than our assumptions. Interstellar objects, known as ISOS, are bodies that belong to no star. They wander between stellar systems like stateless souls, silent and unseen. We recognize them only when chance guides them through our neighborhood, revealing their presence through a precise mathematical signature: hyperbolic orbits with eccentricity greater than 1. Long before the astonishing arrival of 3 I/Atlas in 2025, racing through the solar system at 58 kilometers per second, humanity was startled, then profoundly captivated by 2 earlier pioneers, a strange enigma named Oumuamua and a clearer, more familiar messenger called Borisov. 1I Oumuamua, the strange messenger from the void. The story begins on October 19, 2017, when the Pan-STARRS telescope in Hawaii detected a faint point of light moving far too fast to belong here. It was given the name 1I/Oumuamua, a Hawaiian phrase meaning first messenger from afar, or scout, a shape beyond expectation. Even through our most powerful telescopes, Oumuamua appeared as little more than a single pixel. Yet subtle variations in its brightness revealed something extraordinary. Scientists inferred an extreme shape, either long and narrow like a cosmic cigar, or flat and thin like a drifting disk. Its surface carried a deep reddish hue, reminiscent of objects from the outermost reaches of our solar system, aged by countless millions of years of cosmic radiation, the silence, and the unexplained escape. What truly unsettled astronomers was what Oumuamua did not display. Despite passing closer to the Sun than Mercury's orbit, it showed no gas halo, no dust tail, none of the familiar signs of a comet. This suggested a body stripped of volatile materials, perhaps after eons of wandering through interstellar space. Then came the final surprise. As Oumuamua departed the solar system, it began to accelerate, against expectations. Instead of slowing under the Sun's gravity, it sped away. With no visible jets of gas to explain the thrust, its behavior defied easy explanation. Theories at the edge of understanding. This anomaly sparked years of debate. The nitrogen ice theory, proposing a fragment of an exoplanet similar to Pluto, composed largely of nitrogen ice. The hydrogen ice theory, suggesting a rare body formed in the cold depths of molecular clouds. The artificial technology hypothesis, advanced by Professor Avi Loeb, proposing that Oumuamua could be a fragile light-driven sail created by an advanced civilization. While most scientists regard the latter as speculative, Oumuamua's silence and peculiar motion remain unresolved, leaving its true nature an open question. 2I/Borisov, reassurance from a familiar comet. As debate over Oumuamua continued, the universe offered a second visitor, one that brought clarity rather than confusion. In August 2019, 2I/Borisov was discovered by amateur astronomer Gennady Borisov using a homemade telescope, a quiet reminder that curiosity still belongs to devoted individuals. A textbook comet. Unlike its predecessor, Borisov behaved exactly as a comet should. It displayed a bright coma and a dust tail stretching 14 times the diameter of Earth. In Borisov, astronomers saw confirmation that icy bodies from other star systems can closely resemble those born around our own sun. Chemistry from a distant nursery. Because Borisov was detected while approaching the sun, scientists were able to study it over a longer period. Spectroscopy revealed familiar compounds, water vapor and cyanide, hallmarks of cometary chemistry. Yet Borisov still carried its own signature of otherness. It contained unusually high levels of carbon monoxide, suggesting formation in an extremely cold environment, possibly around a red dwarf star. In early 2020, the comet even showed signs of fragmentation, briefly revealing pristine interior material untouched since its birth. 2 visitors, 1 awakening. Seen together, these 2 pioneers mark a turning point in our understanding. Speed. Oumuamua traveled at roughly 26 kilometers per second. Borisov at 32 kilometers per second, both later surpassed by 3I/Atlas. Size. Oumuamua measured only a few hundred meters, Borisov reached about 1 kilometer, while Atlas dwarfs them both. Meaning, Oumuamua challenged our assumptions, forcing us to widen our imagination. Borisov reassured us that familiar physics extends far beyond our sun. Their appearances, so close together in cosmic terms, have reshaped astronomical expectations. We now understand that the Milky Way continually scatters vast amounts of debris across interstellar space, and that our solar system is merely a brief waypoint in journeys lasting millions of years. As your mind drifts gently among these memories of distant travelers, allow a quiet sense of peace to settle in. Whether Oumuamua was a silent shard of an ancient world, or Borisov a brilliant block of primordial ice, both fulfilled the same purpose. They reminded us that we are not alone in isolation, but participants in a vast, interconnected galactic community, one where even the quietest visitors carry stories older than the stars themselves. Emergence from the darkness, a fateful night in Chile. Our story begins on the quiet night of July 1st, 2025, at the Rio Hurtado Observatory in Chile. Beneath a sky of unwavering stillness, the Atlas Survey Telescope, NASA's final line of early warning against asteroid impacts, was carrying out its familiar routine, patiently scanning the heavens for near-Earth objects. Then, almost imperceptibly, a faint point of light appeared. At magnitude 18, it was barely noticeable, easily mistaken for just another newly discovered asteroid. It was given a provisional name, A11PL3Z. But as automated systems began calculating its trajectory and velocity, a subtle tension settled over the control room. The numbers did not behave as they should. They refused to fit within any known model of motion inside our solar system. The object was plunging toward the sun at an extraordinary speed, 245,000 kilometers per hour, or 58 kilometers per second. To place this in perspective, it was moving 4 times faster than Voyager 1, humanity's fastest and most distant spacecraft. At such speed, it could circle the Earth in just 11 minutes. In that moment, it became clear. This was no local neighbor. It was the third officially confirmed interstellar visitor ever observed, soon to be known as 3I/Atlas, the orbit of a cosmic bullet. What immediately set 3I/Atlas apart from earlier visitors, such as Oumuamua and Borisov, was its orbit. In astronomy, orbital eccentricity tells a simple story. Values below 1 describe objects bound to the sun. Values above 1 reveal travelers that will never return. Oumuamua startled the world with an eccentricity of 1.2. Borisov followed with a more dramatic 3.4. But Atlas shattered all expectations with an eccentricity of 6.14. At this extreme, its path is no longer a graceful arc, but nearly a straight line, like a bullet fired from the depths of the galaxy, cutting cleanly through our solar system. More unsettling still was its direction. Atlas arrived on a retrograde orbit, moving directly against the orderly flow of the planets. Its path is tilted at 175 degrees relative to the ecliptic plane, introducing a profound sense of dissonance, an intruder moving to a rhythm entirely its own, a traveler from the dawn of the galaxy. When researchers at Oxford traced Atlas's motion through galactic space, its origin became clear. This visitor did not emerge from nearby regions of young stars. Instead, it came from the thick disk of the Milky Way, a vast and ancient realm populated by the galaxy's oldest stellar populations, formed when the Milky Way itself was still young. From this trajectory, scientists estimate that 3I/Atlas is between 7.6 and 14 billion years old. Consider that for a moment. Long before the sun ignited, before Earth took shape, Atlas had already begun its solitary passage through the darkness. It may have witnessed the earliest chapters of galactic formation. Within its substance may lie unaltered material from the dawn of time, a priceless cosmic time capsule from a star system that may no longer exist. A geochemical nightmare, carbon dioxide and the missing iron. In August 2025, the James Webb Space Telescope and SphereX turned their attention to Atlas, conducting detailed spectral analyses. What they found unsettled long-standing assumptions. Most comets are icy conglomerates, dirty snowballs, rich in water ice. Atlas is different. Its gas halo is dominated by carbon dioxide, with a ratio of 8 parts CO2 to 1 part water, 16 times higher than that of typical solar system comets. This points to an origin in an environment of extreme cold, far beyond the carbon dioxide snowline of its parent star. Yet the strangest discovery lay deeper. Astronomers detected nickel vapor, but found no trace of iron. In cosmic chemistry, iron and nickel are inseparable companions, forged together in stellar cores. Finding one without the other is exceptionally rare. This imbalance turns Atlas into a geochemical paradox, one that challenges our understanding of how celestial bodies are formed. The physical challenge, the counter-wind tail. Perhaps the most controversial feature of 3I/Atlas is its behavior near the sun. Every comet we know grows a tail that streams away from the sun, shaped by radiation pressure and solar wind. Atlas, however, defied this rule. During July and August 2025, it displayed an anti-tail, a dense stream of material extending toward the sun. This suggests the ejection of heavy, compact dust particles so massive that sunlight cannot easily push them aside. Some researchers, including Professor Avi Loeb, have ventured speculative ideas, proposing everything from advanced energy harvesting mechanisms to artificial control systems. Even more puzzling is Atlas's stability. Despite ejecting enormous quantities of material, its orbit remains unchanged to an astonishing degree. Normally, such outgassing would alter a comet's trajectory. Atlas continues on its path as if it were a single solid mass, or as if it possessed an unknown means of maintaining perfect balance. The silent passage behind the sun. One of the most unsettling coincidences occurs at Atlas's closest approach to the sun on October 29, 2025. Just as solar heating should drive its activity to a peak, Atlas passes completely behind the sun from Earth's perspective. For nearly 3 months, a veil of blinding sunlight prevents observation. Ground-based telescopes fall silent. Even Hubble and James Webb must turn away. This unseen interval may be the most critical phase of all, a time when fragmentation, transformation, or internal processes could unfold beyond our view. Only in early December 2025 will Atlas emerge again, altered in ways we cannot yet foresee. Now, as your mind's vessel drifts toward the edge of this dark frontier, allow a quiet sense of humility to settle in. 3. I/Atlas. Whether an ancient relic from the Milky Way's thick disk or something far more enigmatic, reminds us how small our understanding remains. Imagine it as a solitary ship gliding across the still surface of space-time, carrying the memories of a young galaxy. Let your breathing slow, aligning with the patient rhythm of the cosmos as you drift gently into rest beneath the unchanging halo of the stars. Night travelers, our journey continues tonight as we explore a quiet and profound chapter of the cosmos. A witness of time, the origins and age of 3I/Atlas. You do not need to analyze or remember anything. Simply allow these words to drift toward you like a soft current of light, carrying your thoughts gently through the void. Let your breathing slow, let your mind rest, as we contemplate an entity that has endured since the very dawn of our galaxy, beneath the eternal glow of the stars. The appearance of the ancient giant. The story begins on the night of July 1st, 2025, when the Atlas Survey Telescope system in Chile detected something unusual. A faint point of light was racing toward the sun at a staggering speed, 245,000 kilometers per hour, or 58 kilometers per second. This is 4 times faster than Voyager 1, the fastest spacecraft ever built by humanity. In an instant, astronomers understood that this was no ordinary visitor. It was not another neighbor of the solar system, but the third officially confirmed interstellar object, now known as 3I/Atlas. Yet speed alone was not what truly unsettled the scientific community. What followed was far more profound, an encounter not merely with distance, but with deep time. Based on dynamical models and its position within the Milky Way, Matthew Hopkins and his colleagues at Oxford estimated, at 68% confidence, that 3I/Atlas is between 7.6 and 14 billion years old. For comparison, our solar system formed only 4.6 billion years ago. Atlas may be several times older than Earth itself, a traveler born during the universe's earliest chapters. Origins in the thick disk, a realm of ancestral stars. How can we trace the birthplace of such a small object amid the vast ocean of stars? The answer lies in its motion. When 3I/Atlas entered the solar system, it did not follow the orderly plane shared by nearby young stars. Instead, it carried a distinctive velocity signature, moving away from the galactic center at -51 kilometers per second, while simultaneously rising above the galactic plane at plus 18.5 kilometers per second. This unusually high vertical motion points clearly to the thick disk of the Milky Way. Imagine our galaxy as a layered structure. At its heart lies the thin disk, home to young, metal-rich stars like our Sun. Surrounding it is the broader, fainter, thick disk, populated by much older stellar systems. The thick disk formed some 10 to 11 billion years ago, during a turbulent era when the Milky Way was still assembling itself from primordial gas. 3I/Atlas is debris cast out from that ancient environment. It carries within it the memory of a time when heavy elements, iron, gold, and others, were only just beginning to emerge from the furnaces of the first generations of stars. The universe's speed clock, a slingshot through the ages. Why does Atlas move so swiftly? Astronomers describe its motion as that of a cosmic cannonball. Yet this speed was not inherent from birth. Over billions of years drifting through interstellar space, 3I/Atlas has passed near countless stars and stellar nurseries. Each encounter provided a subtle gravitational push, a slingshot effect, incrementally increasing its velocity. The longer an object wanders the galaxy, the more opportunities it has to gain speed. In this way, Atlas's remarkable velocity serves as a kind of odometer, recording an unimaginably long journey. It has been traveling since long before complex life appeared on Earth, accumulating momentum across the ages. A vanished home. One of the most poignant aspects of 3I/Atlas is that the star system where it was born likely no longer exists. If Atlas truly formed 10 to 14 billion years ago, its parent star has already completed its life cycle. It may have exploded as a supernova, or faded quietly into a white dwarf, a neutron star, or even a black hole. What we see today is a time capsule, material preserved from the universe's chemical infancy. This explains its unusual composition, dominated by carbon dioxide at levels 16 times higher than those found in comets from our own solar system. Atlas formed in a carbon-rich, heavy-element-poor environment, offering us a rare glimpse into a phase of cosmic history that modern science has never directly observed. Hypotheses beyond the horizon. The extreme age and thick disk origin of 3I/Atlas have inevitably inspired bold ideas. Professor Avi Loeb of Harvard has raised a provocative question. Could Atlas be technological in origin? Might an intelligent civilization, emerging 10 billion years ago, have launched devices durable enough to survive for eons? From this speculative viewpoint, 3I/Atlas becomes something more than inert matter, perhaps a form of ghost technology, a silent relic of a civilization long extinguished. Hidden beneath ice and dust, emitting no signals, it would drift unnoticed through young star systems, carrying out a purpose assigned billions of years ago. While such ideas remain unproven, the simple presence of an object nearly as old as the universe itself within our solar system is a humbling reminder. We are newcomers in a very ancient galaxy. Now, as images of thick disk stars, billion-year journeys, and the aging Traveler 3 I/Atlas gently fade, allow a sense of calm to settle over you. You are supported by the vast flow of time itself. The universe is not hostile. It is a patient keeper of memory, preserving fragments of the past so that we may wonder, reflect, and dream. Whether 3 I/Atlas is an ancient iceberg or a silent messenger, it teaches us humility. We live on a young world, yet we have briefly touched the light of something nearly as old as the cosmos itself. Imagine the universe as an immense ancient library. Our solar system is a newly printed book on its shelves. 3 I/Atlas is a rare manuscript, passed down through countless generations, bearing handwriting from the time the library was first built. Tonight, that manuscript passed quietly by our table, leaving behind a trace of deep time before returning to the unreachable archives of the stars. Let the whispers from the far edges of space soothe you now. Even if 3 I/Atlas disappears forever into the interstellar dark, its fleeting visit has already linked us, gently and permanently, to the great source of the universe itself. Night travelers. Tonight, we follow faint traces hidden in the darkness, retracing one of the most extraordinary technological pursuits in human history. Welcome to our in-depth reflection. The observation history of 3 I/Atlas, from darkness to glory. Ghosts in the data repository, the pre-discovery phase. Long before the name 3 I/Atlas, also known as C/2025N1, began to echo through observatories around the world, it had already slipped quietly through the solar system, like a ghost unseen. Its story did not begin on the day of official discovery, but lay buried deep within forgotten terabytes of archived data. In May 2025, NASA's TESS satellite, built to search for distant exoplanets, captured faint images of Atlas when it was still 6.4 astronomical units from the Sun, beyond the orbit of Jupiter. No algorithm raised an alarm. It appeared as nothing more than an anonymous point of magnitude 20, drifting unnoticed among billions of stars. Only later did scientists recover these pre-discovery frames, revealing something quietly astonishing. Even in that frozen realm, Atlas was already active. Ordinary water ice cannot sublimate at such distances. This behavior suggested the presence of far more volatile ices, carbon monoxide or carbon dioxide, awakening long before warmth should have reached them. Soon after, the Zwicky Transient Facility in California recorded additional traces between June 14th and June 21st, 2025. Atlas seemed to conceal itself against the dense star fields near the Milky Way's center, blending into the brilliance behind it. Like a pilgrim moving through a crowded city, it passed unseen, until the moment it stepped into the light. The fateful night in Chile and the awakening of technology. That moment arrived on the night of July 1st, 2025. At the Atlas Observatory in Chile, a bright speck labeled A11PL3Z appeared on the screen. At first, it seemed ordinary, another near-Earth asteroid. Then the calculations began. As orbital data accumulated, a quiet tension spread through control rooms across the globe. The numbers refused to obey familiar laws. Its orbital eccentricity reached 6.14, far beyond anything previously recorded, surpassing Oumuamua at 1.2 and Borisov at 3.4. Its speed was staggering, 58 kilometers per second, more than 200,000 kilometers per hour, fast enough to circle Earth in just 11 minutes. Within 24 hours, the astronomical community mobilized. 122 observations from 31 observatories across 6 continents flooded into the Minor Planet Center. On July 2nd, 2025, the verdict was official. 3. I/Atlas, the third confirmed interstellar visitor in human history. The race of the giant eyes. With its interstellar origin confirmed, a global race began. Astronomers were determined not to repeat the quiet loss of Oumuamua, which had slipped away before revealing its secrets. Hubble, the portrait maker. On July 21, 2025, the Hubble Space Telescope turned its steady gaze toward Atlas. Its images revealed a delicate, teardrop-shaped cocoon of dust flowing from the nucleus. Hubble refined earlier estimates, constraining the solid core to less than 5.6 kilometers in diameter, far smaller than some initial ground-based guesses. James Webb, the chemical decipherer. On August 6, 2025, the James Webb Space Telescope delivered the most profound insight yet. In the infrared, Webb read Atlas's chemical signature with unprecedented clarity. The result was startling. Atlas was not a typical dirty snowball rich in water ice. Instead, it was dominated by carbon dioxide with a CO2 to water ratio of 8:1, 16 times higher than that of solar system comets. VLT, the metal seeker. In Chile, the Very Large Telescope detected cyanide and, more surprisingly, nickel vapor in the coma. Yet iron, normally inseparable from nickel in cosmic processes, was entirely absent. This anomaly defied established models of celestial chemistry. SETI, the listener. Within hours of confirmation, the SETI Institute activated expanded monitoring protocols. The Allen Telescope Array gathered more than 21 terabytes of data in a single week, searching for artificial signals. Officially, the result was silence, though a few amateur reports spoke of repeating patterns, heard every 22 minutes, echoing faintly in the background of the noise. Mars, and the silence beyond the sun. The observation campaign reached its height on October 3, 2025, when Atlas passed within 29 million kilometers of Mars. For the first time, humanity observed an interstellar object from a true planetary vantage point. Orbiters such as Europe's Trace Gas Orbiter and China's Tianwen-1 captured striking images of a vast coma stretching 15,000 kilometers across. Then, as if by design, silence returned. On October 21, 2025, Atlas slipped into solar conjunction, hidden completely behind the sun's glare. For nearly 3 months, no telescope, on Earth or in space, could follow it. This blackout coincided with perihelion, the moment of greatest heat and transformation. Scientists could only wait, holding their breath until December 2025, wondering what changes might unfold unseen. The meaning of an invisible presence. Every atom within 3 I/Atlas may be billions of years older than any atom within your body. It is a time capsule, preserving material from the Milky Way's earliest chemical era. An object perhaps 7 to 14 billion years old, quietly bearing witness to the birth of galaxies. As thoughts of eccentric orbits and spectral ratios gently fade, allow a deep calm to settle in. Atlas, whether an ancient block of ice or a silent messenger from a vanished civilization, offers a lesson in humility. We are young, yet we have learned to capture the light of something almost as old as the universe itself. The universe remains vast, patient, and forgiving, guarding its travelers across time and space. Imagine 3 I/Atlas as a solitary ship gliding across the still surface of space-time, carrying memories from a youthful galaxy. Let these whispers from the frontier soothe your soul. Picture Atlas as an ancient seed, lifted by the galactic wind, drifting across oceans of darkness. Breathe slowly. Let your breath fall into rhythm with the quiet pulse of the cosmos, and drift gently into sleep beneath the enduring halo of the stars. Tonight, night travelers, we turn our attention to a particularly unsettling chapter: the anomalies, when physics is challenged. This is the point where 3 I/Atlas is no longer merely a visitor from afar, but a quiet disruptor, pressing against the very rules we believe govern the universe. The orbit of a cosmic bullet, a challenge to celestial mechanics. It begins, as many great disturbances do, with dry numbers, numbers that carry immense weight. In astronomy, orbital eccentricity, known simply as E, serves as an identity card. For any object securely bound to the Sun, this number must remain below 1. When Oumuamua arrived, an eccentricity of 1.2 stunned the scientific world. Borisov followed, pushing that boundary further to 3.36. Then came 3I/Atlas. Its eccentricity, 6.14, shattered every predictive model ever built. Let that number settle gently into the quiet of the night. With such an extreme value, Atlas's path is no longer a graceful curve around our star. It resembles a near straight line, as though fired deliberately from the depths of the galaxy. Astronomers describe it as a cosmic bullet. Atlas races through space at an over-hyperbolic velocity of 58 kilometers per second, more than twice the speed of Oumuamua, and far beyond anything humanity has ever launched. Yet speed is only part of the defiance. Atlas travels in a retrograde orbit, tilted almost completely, 175 degrees, against the ecliptic plane. It enters the solar system not with the flow of planets, but against it, moving stubbornly in the opposite direction. Combined with its immense velocity, this creates a relative speed of up to 98 kilometers per second with respect to Earth, rendering any interception with current chemical propulsion utterly impossible. It is not merely passing through, it is moving against the grain of the solar system itself. The geochemical nightmare, the vanishing of iron. If Atlas unsettles mathematics, its chemistry unsettles something deeper. Imagine standing within the quiet precision of the James Webb Space Telescope, where infrared light is separated into delicate bands that reveal the hidden nature of matter. In August 2025, Webb examined the glowing coma of Atlas and uncovered a startling imbalance. Nickel vapor was present, iron was not. In the cosmic order, iron and nickel are inseparable companions. They are forged together in the dying hearts of massive stars, expelled together in supernova explosions, and found together everywhere, from asteroids and comets to planetary cores. Their origins and behaviors are so closely linked that finding one without the other is extraordinarily rare. On Earth, such separation requires complex industrial processes. Yet in Atlas, nickel stands alone. This absence raises questions without easy answers. What force separated these elements before Atlas ever formed? Did it emerge from an environment governed by physical conditions we have yet to imagine? Or does this imbalance hint at refinement, at structure shaped rather than merely born? The giant dry bomb, the carbon dioxide paradox. The universe often reveals its secrets through contrast. Most comets in our solar system are familiar creatures, dirty snowballs, rich in water ice. As they approach the sun, heat transforms ice into vapor, producing luminous halos and graceful tails. Atlas follows a different script. James Webb's data shows that its coma is dominated by carbon dioxide, with a ratio of 8 parts CO2 to 1 part water, 16 times higher than that of typical comets. Atlas is not a reservoir of water ice, but something closer to a vast interstellar dry ice body, drifting silently through space. This composition explains another early mystery. Atlas became active far from the Sun, beyond Jupiter's orbit at 6.4 astronomical units, where water ice should remain frozen. Carbon dioxide, however, can sublimate even in such deep cold. Its early awakening suggests a birthplace far beyond the carbon dioxide snowline of its parent star, an environment colder and older than those that shaped our own solar system. The counter-wind tail, defying radiant pressure. Now let your thoughts soften for a moment. Imagine a sailboat on calm water. Wherever the wind blows, smoke and sails follow. In space, the sun plays the role of that wind. its radiation and solar particles pushing cometary dust and gas away. This is why, without exception, comet tails point from the sun outward. Until 3 I/Atlas. During July and August 2025, astronomers observed something profoundly unsettling: a brilliant anti-tail streaming directly toward the sun. Atlas appeared to eject particles so large and heavy that sunlight itself could not push them back. A dense river of matter flowed forward, thousands of kilometers long, leading rather than following. Such a counterwind tail challenges one of the most fundamental behaviors taught in astronomy. Some have speculated it might function as a protective dust screen, shielding the object as it travels at interstellar speed. Whatever the cause, the phenomenon stands as a quiet rebuke to textbook physics. The silence and the paradox of acceleration. When a comet releases gas, it behaves like a natural rocket. Material expelled in one direction nudges the nucleus the other way, altering its path. Oumuamua exhibited such unexplained acceleration as it departed. Atlas once again refused to follow precedent. Despite ejecting tons of material every second, precision measurements show that its orbit remained unchanged, not by a millimeter. It moved with unwavering accuracy, as though extraordinarily dense, or guided by a system capable of maintaining perfect balance despite mass loss. This silence extended beyond motion. The SETI Institute gathered more than 21 terabytes of radio data, listening for any artificial signal. The result was absolute quiet, no transmission, no whisper. It is this combination, mathematical defiance, chemical imbalance, physical contradiction, and total silence, that led Harvard professor Avi Loeb to suggest a haunting possibility: ghost technology, a construct so advanced it could hide seamlessly within natural material, observing patiently without leaving a trace. Now, night travelers, allow these anomalies to drift gently into the background of your thoughts. Whether Atlas is an ancient natural body shaped by unfamiliar physics or something far more deliberate, it reminds us of a simple truth. The universe is deeper, older, and more subtle than our certainty. Let that thought rest with you. Breathe slowly and drift onward beneath the calm and watchful silence of the stars. Take a slow, deep breath. Let your chest expand and feel the weight of a long, exhausting day begin to loosen. Imagine yourself resting on a quiet, imagined boat, drifting gently across a velvet ocean of space, where the faint light of distant stars weaves an endless tapestry of reality. If you are lying down now, allow your body to soften just a little more. There is nothing you need to understand, nothing you need to remember. Just listen. There are nights when the sky seems to do nothing at all. It simply exists, silent, deep, and seemingly indifferent to human thought. The night of July 1st, 2025, was one of those nights. The automated telescopes of the Atlas project were quietly scanning the heavens. No one watching, no emotion involved. Just mechanical eyes performing their steady work, like slow, patient breathing. Then, a small point of light appeared. It was not bright, not dramatic, not the kind of thing that would immediately capture attention. It was simply slightly different from the background stars. An algorithm noticed that difference. A computer flagged it. And in that quiet, unremarkable moment, an object that had wandered through interstellar darkness for millions, perhaps billions, of years was given a name. 3I Atlas. The number 3 sounds small, but it carries great weight. Before this moment, humanity had detected only 2 visitors from beyond our solar system. Twice in the entire history of modern astronomy. This third arrival was no longer a coincidence. It was a subtle reminder that interstellar space is not as empty as we once believed. The story truly begins that same night at the Rio Hurtado Observatory in Chile. Edward, an astronomer, sat in front of his computer screen, a cup of cold coffee beside him. unaware that he was about to witness a moment that would quietly reshape our understanding of the cosmos. The Atlas Survey System, NASA's global early warning network for near-Earth objects, had detected something unusual. A faint point of light, temporarily labeled 11PL3Z, had entered its field of view. At first, this was routine. Normally, Edward would compare the data against known asteroids and move on. But this time, the numbers on the screen refused to settle. They shifted and jumped in ways he had never seen before. The object's speed was extraordinary, 245,000 kilometers per hour, or 58 kilometers per second. For perspective, this was 4 times faster than Voyager 1, humanity's fastest spacecraft, and fast enough to circle the Earth in just 11 minutes. Why did this cause such alarm? The answer lies in a quiet mathematical value known as orbital eccentricity. Any object bound to the Sun must have an eccentricity below 1, but Atlas shattered that rule. Its eccentricity reached 6.14, a record beyond anything previously observed. With a value so extreme, its path was no longer a graceful curve, but nearly a straight line. Astronomers described it as a cosmic bullet, fired from the depths of the galaxy straight into our solar system. What made this even more unsettling was how late it was discovered. Amateur astronomer Sam Dean later found that Atlas could have been visible weeks earlier, but it had passed directly in front of the dense star fields near the Milky Way's core. Against that crowded backdrop, detection was nearly impossible. Whether this concealment was coincidence or chance alignment remains unanswered, but it marked the beginning of deeper questions. 3I/ATLAS does not orbit the Sun. It does not belong here. Its path is open, meant only for those who arrive and depart. It came from too far away and at too great a speed to have been born in our solar system. If you could trace its journey backward through time, you would not see Earth. You would not see the Sun. You would see only vast, cold emptiness, regions where light takes decades to travel, where time itself seems to move differently. Atlas may once have circled another star, a distant sun. Perhaps that system collapsed. Perhaps a gravitational encounter flung it outward, turning it into a cosmic exile. From that moment on, it simply drifted. No destination, no intent, just motion. Millions of years passed in silence. No warmth, no sound, near absolute cold. Then, much later, a star appeared ahead. Light intensified. Heat reached its frozen surface, and for the first time in ages, Atlas began to change. Ice sublimated, gas escaped, fine dust rose, forming a faint, hazy veil, a quiet signal that it had entered a place of light. That was when humanity finally noticed. Telescopes across the world turned toward it. The most sensitive instruments, including the James Webb Space Telescope, began examining the light reflected from that thin envelope of gas. Not to search for intelligence, not for spectacle, but to read its chemistry. What they found was both familiar and strange. There was water, there was carbon monoxide, but the proportions were wrong, like a familiar voice speaking with an unfamiliar accent. Webb revealed that Atlas's coma was dominated by carbon dioxide, with a ratio of 8 parts CO2 to 1 part water, 16 times higher than typical comets. This was not a simple, dirty snowball. It was more like a vast interstellar dry bomb. This composition explains why Atlas became active far beyond Jupiter's orbit, at 6.4 astronomical units, where water ice remains frozen solid, but carbon dioxide can already sublimate. It was formed in an environment far colder than our own, beyond the CO2 snowline of its parent star. Yet the deepest unease came from its metals. Astronomers detected nickel vapor in its gaseous halo, but no iron at all. In nature, iron and nickel are inseparable, forged together in stellar cores. Finding nickel without iron is extraordinarily rare, typically requiring industrial separation. This raised a troubling question. What force separated these elements before Atlas ever formed? Its shape added to the mystery. Every comet we know develops a tail pointing away from the sun. Atlas did not. It displayed an anti-tail, ejecting heavy particles that streamed toward the sun instead. Some researchers suggested this behavior was not passive at all, but deliberate, possibly a protective response. Even more puzzling, despite ejecting tons of material every second, a process that should have altered its course, Atlas did not deviate by even a fraction. It moved with perfect precision, as if governed by an internal balance we do not yet understand. And then there was the silence. The SETI Institute collected more than 21 terabytes of radio data, yet heard nothing. No signal, no pattern, only emptiness. Unofficially, some amateurs claimed repeating sounds or mathematical sequences. Officially, there was no comment. What remains is simple. 3I/ATLAS was born elsewhere, in another environment, with another history. A frozen memory from a star system long gone, passing briefly through our own. Outside the laboratories, people began to speculate. On social media, they shared wonder and unease. Not because they wished to be wrong, but because the universe, when it grows vast enough, invites imagination. Science, however, remains patient. It listens. And the data tells us that Atlas is simply an interstellar comet. Nothing more. Nothing less. Unaware that billions of eyes are watching. And still, it is beautiful. A tiny iceberg carrying the story of a place we will never reach passes quietly through our solar system, then continues on, back to the cold and darkness it knew long before we existed. Perhaps there is comfort in that silence, a reminder that we are small, that we are not the center, that the universe does not need us, yet allows us to witness it, briefly. If sleep is coming, let the thought drift away. Do not hold it. Like 3I/ATLAS, it arrives, it departs, and the universe continues to breathe. Slowly, deeply. Are you still awake, night travelers? If you have already drifted into sleep, that is a beautiful thing. And if you are still awake, or floating somewhere between wakefulness and dreams, let this quiet story continue to unfold. In the very short span of modern astronomy, humanity has noticed only 3 moments when an object from outside our solar system passed silently through our cosmic neighborhood. 3 times. In a universe nearly 14 billion years old. And each time, the emotional response was strikingly similar. Curiosity, humility, and a gentle sense of disorientation. The first encounter came in 2017. The object was named Oumuamua, a Hawaiian word meaning the messenger who arrives first. The name was fitting. Oumuamua carried a quiet but profound message. The solar system is not sealed. Things arrive from far away, pass by briefly, and do not pause for us to understand them. Oumuamua was unlike anything ever observed before. It displayed no familiar cometary tail, no surrounding cloud of gas. Its reflected light changed unpredictably, suggesting a shape that was unusually elongated, perhaps like a cigar or a leaf tumbling through space. Even more puzzling, it accelerated as it left the sun in a manner that standard physical models could not easily explain. That silence, that refusal to conform, awakened the human imagination. Some spoke of technology, others imagined light sails or artificial structures. But what lingered longest was not the speculation, it was the feeling. A realization that we were unaccustomed to visitors from beyond our stellar home. Then Oumuamua was gone. It departed too quickly. By the time deeper questions formed, it had already vanished, carrying its ambiguity with it. 2 years later, in 2019, another visitor appeared. This time it felt different. The object was named 2I/Borisov, and from the beginning, it behaved like a comet we recognized. It had a tail, it had a coma, it released gas and dust as it approached the sun. Borisov seemed to reassure scientists, quietly saying, "I am foreign, but not unfamiliar." Measurements revealed that Borisov's chemical makeup closely resembled that of comets formed within our own solar system, with only subtle variations. It came from another star system, yet emerged from conditions that felt surprisingly familiar. Borisov brought comfort. It allowed science to exhale. It suggested that even across vast distances, the universe often follows repeating patterns. And then, the years passed. No new visitors arrived. The sky returned to its familiar rhythm, until 3I/ATLAS appeared. Atlas arrived in a different era, an era of greater experience, more sensitive telescopes, faster data processing. Humanity was no longer startled by the idea of interstellar travelers. And yet, 3I/ATLAS did not fit neatly into what we had learned. It was not as starkly mysterious as Oumuamua, nor as comfortably familiar as Borisov. Atlas possessed a coma. It released gas. It responded to sunlight. But the ratios of those substances, carbon monoxide, carbon dioxide, water, told a different story. One that caused scientists to pause a little longer over their charts. If Oumuamua was an unanswered question, and Borisov a reassuring answer, then 3I/ATLAS feels like a quiet passage between the two. It suggests that other star systems produce not only comets, but comets with distinct characters. Each interstellar object becomes a variation on the same ancient theme: ice, dust, gravity, and time. Comparisons naturally followed: orbits, velocities, chemical reactions to light, and within those comparisons, something subtle changed. These objects were no longer seen as alarming anomalies. They became visitors, each carrying the memory of another place. Oumuamua, the one who arrived swiftly and departed just as quickly, leaving questions behind. Borisov, the courteous guest, allowing us time to observe and understand. 3I/ATLAS, the quiet storyteller, not shocking, but different enough to remind us that the universe is not uniform. And like the two before it, Atlas will also leave. It will not wait for full understanding. It will not turn back. It will continue onward, crossing vast regions of space that exist only in human imagination. What remains is a light, almost weightless feeling that we are part of a much larger flow. And occasionally, that flow carries something past us, just long enough for us to notice, and then let it go. Now together, we turn to the story of a man who dared to challenge convention, proposing ideas that seemed to belong more to science fiction than academic journals. Welcome to Avi Loeb and the Ghost Technology Hypothesis. In the disciplined world of science, guided by caution and restraint, Avi Loeb stands out as a contradiction. He is not an unfounded dreamer. He is a professor of astrophysics at Harvard University, former chair of its astronomy department, and an advisor to the Breakthrough Listen project. With credentials such as these, why does he so often explore ideas that feel speculative, even unsettling? The answer traces back to 2017, with the arrival of Oumuamua. Its unusual shape and unexplained acceleration prompted Loeb to suggest something radical, that it might be an artificial solar sail. While many searched for purely natural explanations, Loeb argued that ignoring alternative possibilities could limit scientific inquiry. When 3I/ATLAS appeared in 2025, Loeb once again stepped into controversy with his concept of ghost technology, devices so advanced they could disguise themselves beneath the surface of natural celestial bodies. Loeb insists that science must remain open, He warns that dismissing anomalies too quickly as natural may sometimes reflect intellectual complacency. To him, scientific papers are not declarations of truth, but structured thought experiments, valuable even if later disproven. His interest in Atlas rests not on intuition, but on anomalies that strain conventional models. First, the orbit. With an eccentricity of 6.14, Atlas follows a path so extreme it is nearly linear. Loeb notes that this trajectory brings it unusually close to Venus, Mars, and Jupiter, with a probability of random occurrence estimated at just 0.005%. To him, this suggests intentional navigation rather than chance. Second, the timing. On October 29, 2025, as Atlas reaches perihelion and becomes most active, it will be hidden behind the Sun from Earth's perspective. This 3-month observational blackout, Loeb argues, would be an ideal window for a technological probe to adjust its course or deploy instruments without detection. Then there is the anti-tail, a stream of material pointing toward the Sun, defying expectations. Loeb proposes that this could represent an energy harvesting mechanism or a defensive system protecting the object at extreme velocities. Chemically, Atlas deepens the mystery. James Webb data reveals carbon dioxide levels 16 times higher than those of typical comets. More striking still is the presence of nickel alongside the complete absence of iron. On Earth, such separation requires industrial refinement. Loeb suggests this could indicate a shell composed of heat-resistant nickel alloys, similar to those used in advanced aerospace engineering. As for the radio silence, despite SETI's analysis of over 21 terabytes of data, Loeb invokes the dark forest theory. In a universe where civilizations hide to survive, silence may be the most advanced strategy. Seen through this lens, 3I/ATLAS becomes a technological ghost, an ancient probe, possibly billions of years old, sent by a civilization long vanished. It drifts quietly through young star systems, concealed beneath ice, observing without revealing itself. Whether this interpretation is correct or not, Loeb believes Atlas confronts humanity with an unsettling possibility, that we may not be alone, and that we may not be the most advanced observers in the cosmos. And in the quiet of the night, that thought lingers, softly, patiently, like a distant star whose light has only just reached us. We will not only pause to admire the quiet beauty of the stars, but gently step into a far more unsettling territory, a battle of intellect between established scientific conviction and hypotheses so bold they verge on the unbelievable. Tonight, we explore the critique and the hidden questions surrounding the third known interstellar visitor, 3I/Atlas. There is no need to analyze, no need to debate. Let these words move like a soft current of light, carrying your thoughts into the vastness, where truth and illusion are often separated by nothing more than a thin veil of cosmic mist. Allow your breathing to slow. Let the night do the rest. When the numbers begin to whisper. Our story begins not with speculation, but with numbers, quiet, precise, and deeply unsettling. On July 1st, 2025, 3I/Atlas, also cataloged as C/2025N1, appeared with an orbital signature that left astronomers staring in disbelief. Its eccentricity measured 6.14, a value so extreme it shattered every predictive model. Unlike Oumuamua or Borisov, which traced broad curves through the solar system, Atlas moved almost in a straight line, racing forward like a cosmic bullet at a staggering 58 kilometers per second. It was within this storm of data that Professor Avi Loeb of Harvard University, already known for challenging conventional interpretations of interstellar objects, raised his voice. He did not see Atlas as a lifeless fragment of ice. He saw intention. Loeb argued that the probability of a random object passing so close to Venus, Mars, and Jupiter with such precise timing was just 0.005%. To him, this did not resemble coincidence, but planning. He paid special attention to October 29, 2025, the moment Atlas would reach perihelion while being completely hidden behind the sun from Earth's viewpoint. This, Loeb suggested, created an ideal observational blind spot, a perfect window for concealment maneuvers or the deployment of secondary probes. He called it ghost technology. The counterargument, the iron wall of traditional science. The response from mainstream science was swift and unyielding. Many researchers rejected the intrusion of speculative ideas into a discipline grounded in reproducible evidence. Chris Lintott of Oxford University, who helped model Atlas's galactic origin, dismissed the artificial origin hypothesis as nonsense on stilts. To him, inferring extraterrestrial intent from incomplete orbital data undermined serious scientific work. Astrophysicists such as Scott Manley and David Kipping highlighted weaknesses in Loeb's statistical reasoning. They argued that once an orbit is known, it is always possible to identify striking alignments after the fact. In a galaxy filled with trillions upon trillions of wandering objects, close planetary encounters could still arise purely by chance. Size estimates became another point of contention. Early reports suggested Atlas might span up to 20 kilometers, supporting Loeb's interpretation of a massive artificial structure. Later observations from the Hubble Space Telescope, however, constrained the solid nucleus to less than 5.6 kilometers. The apparent size, mainstream scientists argued, came from its expansive carbon dioxide halo, not from a metallic shell. The wall of conventional explanation appeared solid. Yet, upon closer inspection, subtle cracks remained. The hidden questions, where the wall begins to fracture. Even the strongest counterarguments struggle to fully account for several troubling anomalies, details that current physical models address only vaguely. The geochemical puzzle, nickel without iron. Spectroscopic data from the Very Large Telescope revealed the presence of nickel vapor in Atlas's halo. At first glance, this seemed unremarkable, but iron, nickel's inseparable cosmic partner, was entirely absent. In nature, these two elements are forged together in stellar cores and ejected together in supernovae. Their separation is extraordinarily rare and typically requires industrial refinement. Mainstream science offers cautious explanations involving unusual formation environments, yet these remain speculative, while the detection of nickel is unequivocal. The physics of the rebellious tail. During July and August 2025, Atlas displayed an anti-tail, streaming thousands of kilometers toward the sun. Standard models attribute this to unusually large dust grains, unaffected by radiation pressure. But ejecting such massive particles at such velocity would require immense internal energy. Loeb posed a quiet question. Could this represent an active protective mechanism shielding a core traveling at interstellar speed? The silence of MAVEN and the Glomar response. Perhaps the most unsettling questions arise not from the sky, but from Earth. As Atlas approached Mars, an ideal opportunity for close observation, NASA's MAVEN spacecraft abruptly entered safe mode and ceased operation. The timing could not have been more critical. Shortly afterward, the CIA invoked the National Security Act of 1947, issuing a Glomar response, refusing to confirm or deny the existence of related records. Why would an icy interstellar object provoke such secrecy? Explanations involving technical faults or solar interference feel strangely insufficient beside the weight of legal silence. Could Loeb be partly right? When viewed as a whole, the picture resists simplification. Atlas may not resemble the sleek spacecraft of fiction, yet it is equally difficult to dismiss it as a random fragment of stone and ice. Its precise planetary encounters, anomalous chemistry, and the involvement of security agencies suggest something beyond the ordinary. Even Loeb's critics concede one extraordinary fact. Atlas may be older than any known object ever observed, possibly up to 14 billion years old, nearly as old as the universe itself. An entity born in such a distant epoch may not conform neatly to physical laws we have only understood for a few centuries. Loeb's interpretation of the dark forest theory offers a haunting explanation for Atlas's silence. In a universe where survival depends on remaining unseen, the safest signal is none at all. Atlas passes like a ghost, quiet, concealed, performing its observations beneath a natural disguise. Now, as your thoughts drift farther into the dark frontier, feel the calm of perspective return. The debate between Avi Loeb and the scientific community, however intense, is only a single ripple in a vast ocean of knowledge. There is no need for a final answer. 3I/Atlas, whether a shard of ancient ice from the Milky Way's thick disk or a silent messenger from the abyss, offers us something far more valuable: the courage to question and the freedom to imagine. We are young beings on a small world, yet we have captured the light of something nearly as old as the universe itself. The cosmos remains silent and patient, guiding interstellar travelers across time and space. Picture Atlas as a solitary vessel gliding across the smooth surface of space-time, carrying the memory of a star system that vanished billions of years ago. Let these distant whispers soothe your mind. Imagine 3I/Atlas as an ancient dandelion seed, carried by galactic winds across endless darkness. Let your breathing fall into rhythm with the slow pulse of the universe, easing you into rest beneath the eternal glow of the stars. Even if Atlas never returns, its brief passage has already bound us, quietly, permanently, to the deepest source of all that exists. Tonight, I would like to set aside the dry figures found in textbooks and share something far more elusive with you: a feeling. A quiet, persistent unease that arises when we look up at the night sky and realize that something is moving across it. Something that does not belong to this world, and perhaps does not even belong to nature as we have always understood it. That something is 3I/Atlas, a solitary wanderer that broke the long silence of our solar system in the summer of 2025, carrying questions capable of unsettling even the most rational mind. Are we merely observing a cosmic object, or are we, in some quiet way, being observed by an intelligence whose origins reach back to the dawn of time? It began like the opening scene of a science fiction story, yet it unfolded not on a screen, but in reality. On the night of July 1st, 2025, in Chile, the Atlas telescope system detected a faint point of light, later designated A11PL3Z. At first, it seemed unremarkable, just another inert rock drifting through space. But when mathematicians began calculating its orbit, a shiver passed through the scientific community. Its orbital eccentricity measured 6.14, a staggering value that transformed its path from a gentle curve into something closer to a projectile, fired straight into the heart of the solar system from the depths of the galaxy. In a universe defined by rotation and balance, Atlas chose a nearly straight trajectory, racing forward at 61 kilometers per second, fast enough to circle the Earth in just 11 minutes, faster than any spacecraft humanity has ever built. Yet what truly unsettled me was not its speed, but its manner of arrival. For nearly a month, Atlas remained hidden against the densest star fields of the Milky Way, blending perfectly into the luminous background until it revealed itself at the last possible moment. It was like a figure standing motionless in a brightly lit corridor, invisible until it steps forward. Why would a natural object approach from such a precise, concealing angle, one that effectively blinded our early warning systems? Coincidence begins to feel like an insufficient explanation, and when we look closer, the unease deepens. Professor Avi Loeb of Harvard, often dismissed by more conservative colleagues as an eccentric thinker, proposed a hypothesis that forces us to reconsider our assumptions about the universe. According to Loeb, Atlas is not a comet at all. It is ghost technology. Consider this carefully. Scientists at Oxford estimate that Atlas is between 7.6 and 14 billion years old. Older than Earth, older than the Sun, possibly formed when the first galaxies were still taking shape. If Atlas is technological in origin, then its creators likely vanished into cosmic dust billions of years ago, leaving behind a probe so resilient it could traverse millions of light years and remain intact. This would not be a gleaming spacecraft, fashioned for spectacle. It would be something far subtler, an object disguised beneath ice and dust, drifting quietly through star systems like a loyal instrument carrying out the last instructions of a civilization long gone. The discomfort grows when we examine its chemistry. Observations from the James Webb Space Telescope revealed that Atlas is dominated by carbon dioxide at levels 16 times higher than any known comet in our solar system, more like a vast reservoir of dry ice than a typical dirty snowball. But the true shock lies in the metals. Astronomers detected nickel vapor, yet found no trace of iron. In nature, iron and nickel are inseparable companions, forged together in the cores of stars. Separating them requires complex industrial processes. This raises an unsettling question. What exactly is Atlas made of? Could it be constructed from nickel-based superalloys, materials humans use in jet engines and spacecraft hulls to endure extreme heat and stress? Its silence only deepens the mystery. The SETI Institute collected more than 21 terabytes of radio data from Atlas, yet officially detected nothing at all. Only silence. This brings to mind the dark forest theory, the idea that the universe is a vast, shadowed woodland where every civilization is a cautious hunter. To survive, one must remain silent, because any sound may attract something far more dangerous. If Atlas belongs to such a civilization, it would never announce itself. It would simply observe, quietly recording our atmosphere, our biosphere, our technological signatures, before departing without a word. Unconfirmed reports from amateur astronomers describing repeating signals every 22 minutes only add to the sense that something may be happening beneath that frozen surface, something never fully acknowledged. And then there is the moment near Mars. In October 2025, as Atlas passed close enough for unprecedented observation, NASA's MAVEN probe suddenly entered safe mode and fell silent at the most critical instant. A coincidence, we are told. Yet questions linger. Was a switch quietly thrown to prevent certain images from being seen? Images that might reveal a metallic shell or artificial structure hidden beneath the gas and dust. When pressed, the CIA invoked the National Security Act of 1947, issuing a GLOMAR response, neither confirming nor denying the existence of any related information. This level of secrecy is typically reserved for nuclear weapons and covert military operations. Why would an interstellar rock require such protection? As you lie there, listening, you do not need to decide what to believe. Perhaps Atlas is only an ancient fragment of ice, shaped by forces we have yet to fully understand. Or perhaps it is something far older, far quieter, and far more deliberate. Let the question remain unanswered. Sometimes the universe does not demand certainty, only humility. Atlas's strangeness seems to stand in quiet defiance of the physical laws we thought we understood. You may know that every comet we have ever observed carries a tail pushed away from the sun, sculpted by radiation pressure and solar wind. Yet Atlas does something profoundly different. It reveals a luminous anti-tail, pointing directly toward the sun itself. It appears to be deliberately expelling large, heavy particles forward along its path, as if leading its own passage through space. The motion is reminiscent of an active shielding mechanism, something designed to clear obstacles while traveling at interstellar speed. More unsettling still, despite releasing enormous quantities of material every second, a process that should generate thrust and disturb its course, Atlas holds its trajectory with extraordinary precision. It does not drift. It does not waver. It moves like an object governed by an internal coordination system, steadfastly maintaining direction in defiance of natural sublimation and momentum. Professor Avi Loeb drew attention to another detail that is difficult to ignore. Atlas's orbit appears almost synchronized, approaching Venus, Mars, and Jupiter with astonishing mathematical accuracy. The probability of a random object achieving such a sequence is calculated at just 0.005%. This does not resemble the aimless wandering of cosmic debris. It resembles a route, one plotted and fixed billions of years ago, like a reconnaissance path patiently awaiting its moment. The suspicion reaches its peak on October 29, 2025, when Atlas arrives at perihelion. At the height of its activity, it will be completely hidden behind the sun from Earth's point of view. This extended observational blind spot creates ideal conditions for concealment, redirection, or even the deployment of smaller probes, actions that could unfold beyond the reach of our telescopes and instruments. One cannot help but wonder, could Atlas be a message in a bottle, cast into the cosmic ocean from a past we have never known? Every atom within it is likely older than any atom in your body or mine. For billions of years, it has drifted through darkness, gathering speed from the gravitational touch of countless stars, until it became the swift and silent traveler we see today. Perhaps it witnessed the collapse of the civilization that built it, and now continues its mission alone, an orphaned machine observing for an audience that no longer exists. From the perspective of ordinary people like us, Atlas inspires a deep and humbling awareness. We are young beings on a small world, yet we are granted a fleeting glimpse of something nearly as old as the universe itself. Mainstream scientists may assure us that Atlas is merely an unusually strange comet, but the unanswered questions persist. The precision of its path, the anomalous nickel-without-iron composition, the sudden silence of the Maven probe, and the unusual involvement of security agencies all hint at something that feels distinctly unnatural. Atlas is not coming to strike the Earth. It is not a destroyer, but it carries a different kind of disturbance, a challenge to our perception, and the quiet possibility that we may be observed by an intelligence far beyond our understanding. It is like an ancient dandelion seed, carried by the galactic wind across immense oceans of darkness, briefly drifting past our window before disappearing forever into the interstellar night. Now, as Atlas slowly recedes into shadow, returning to its long and silent journey, allow yourself a sense of calm. We may never know what it truly was, but its brief presence has linked us, however faintly, to the deepest source of the universe itself. The cosmos remains vast, patient, and forgiving, guiding travelers across time and space. Let the distant whispers from the edge of space soften your thoughts. Let them ease you toward rest, beneath the steady glow of the stars. Do not fear the immensity around you, for it is within that immensity that we come to understand how rare and precious our moment truly is. Atlas is like an exceedingly rare handwritten manuscript that glides across our table in an ancient, endless library. It leaves behind a faint scent of time, a few unreadable lines, and then is returned to the deepest archive of the galaxy, one humanity may never reach. Sleep peacefully under the quiet watch of starlight. The unseen universe is always there, holding you in its gentlest silence. Good night, night travelers.